So as I mentioned before, most of chapter 5 will be looking at chemical equations. And basically the rule for chemical equations is that elements in is equal to elements out, which is basically the law of conservation of mass, which we have tried to figure out last time in chapter R, or chapter 1 rather. Now, that just means that how many elements you have in the product side should be how many elements you start with in the reactant side. Now, the chemical equation actually tells us a lot of information, such as, for example, how each reactant reacts at a specific ratio with each other to produce a specific ratio of products. That will be stoichiometry. But most importantly, it also tells us the states of the system. So we have, for example, here reaction between acetic acid and sodium carbonate, which is usually done with high school laboratories, such as illustrated in this GIF. So if you have a solution, or if you have a compound or a substance which is given by the letter S, that just means that you have a solid substance. Liquid means. Now, it is important to balance chemical reactions, and we will do some examples in this video. Now, one thing that I think, a trick that I actually found useful will be, if you're going to balance chemical reactions, you want to balance everything first except for these four. Okay? Now, when you're left with those four, you're actually going to work with nitrogen, okay, and then afterwards work with carbon and hydrogen. I usually put oxygen as the last to balance, and I'm going to show you some examples why. So let's answer this problem. Okay, so let's balance the first reaction. We have on the left side of the equation one copper atom, okay, one atom, or one molecule rather, of S8, and then one molecule of copper sulfide. Okay, so we have to make sure that elements in the product side are equal to the elements in the reactant side. So if we have 8 sulfurs in the reactants, we're going to probably need an 8 here. But if we do that, we actually now have 16 coppers in the product side. No problem. We can just put a 16 here. 16 here. And after that, the equation is balanced. No need to put in here 1. Okay? The absence of coefficient just means that you have one of that substance. Excuse me. Okay. Next, let's go to the next problem. You have oxygen here and hydrogen. Let's balance first the phosphorus. So we have 4 on the reactant side. Let's actually put 4 here for H3PO4. That gives us now 12 hydrogens in the reactant side. So that's 4 times 3. Okay. But we also now have 16, 4 times 4 oxygens on the product side. And so far we have only 2 hydrogens on the reactant side and 11 oxygens. So what we can do is put a 6 here, and if we do that, that actually balances out everything. Okay, let's now try for letter C. Okay, let's go first with, again, sodium and boron. I'll say let's start first with sodium. Okay. So let's give this a first shot. So we have here 3 of nitrogens, 3 of sodiums. Okay, so we can actually put here a 3. We can actually put here a 3 before sodium hydroxide. Okay, but notice that on the reactant side, you actually have two borons. Okay, so if you actually put here two borons, okay, then you will now have a total of 6 sodiums on the product side. So instead of putting here a 3, how about we put instead a 6? Okay, that actually balances out sodium and boron on both sides of the equation. And now let's check for balancing hydrogen. So right now on the reactant side we have 6 and we only have 2 on the product side. So if we put here a coefficient of 3 before water, okay, that will give us equal numbers of hydrogen on both sides of the equation. Now also note that we have a total of 2 times 3, 6, plus 3, 9 oxygens on the product side. And here we have 1, 2, 3 from boron oxide and 6 from sodium hydroxide. So oxygens and hydrogens are also balanced. Okay, let's try here this equation. Let's balance again first the nitrogens. So let's see that now if we have 2 nitrogens here, let's try to put here 2. Okay, I'm just writing that as a small number because we're actually going to have to change that. Okay, I'll say the next thing that we have to do will be to balance the hydrogens. Okay, right now on the reactant side, we actually have 2 times 3, 6, plus 2 times 2, 4. We have a total of 10 hydrogens on the reactant side. Okay, let's just write this down. So 10 hydrogens in the product or in the reactant, and we only have 2 on the product side. So if we multiply H2O, for example, by 5, okay, then well, let's actually just write a smaller number, 5. Then hydrogens will be balanced. That actually leaves us with oxygen. Okay, we have a total of 1, 2, 3, 4 oxygens plus 5, 9 oxygens on the product side, and we have 2 on the reactant side. Now, it would have been easier to balance this if only that oxygen was monatomic oxygen, but it's not. Now, if we, for example, however, multiply this oxygen with 9 halves, okay, then this would have already balanced the reaction. So 9 over 2 times the oxygen just means that you have 9 O2 molecules. That's actually what the fraction means. Now, this is actually a perfectly balanced equation. You may end here actually, but I don't know. I actually don't like working with fractions. So to get rid of this fraction, we have to multiply all of those stoichiometric coefficients by 2. If we do that, we're going to get here 4. Okay, 9 halves divided by 9 halves times 2 is actually 9. Okay, then this one becomes 4. This one becomes 10. And this one becomes 2. So there you go. That's why it's actually kind of important to balance oxygen last. And usually it's for these kinds of reaction wherein oxygen is a reactant. It's combustion reactions. Okay, it's usually for combustion reactions. So here's another example of combustion reaction, letter E. So for this case, I'll say let's balance carbon first. We're actually left with the 3 that we want to left behind anyway. So let's balance carbon first. That will actually, we will have to put then a 4 here. Okay, in the reactant side. Now let us balance hydrogen next. So if we do that, we can put here a 5. Okay. Now now let's try to see if the carbons are balanced. So we have 4 carbons on the reactant side and 4 carbons on the product side. Good. And then we also have 10 hydrogens on the reactant side and 10 hydrogens on the product side. The only thing which is left unbalanced will be oxygen. Okay, oxygen right now, there's actually 2 only in the reactant side, and we have a total of 4 times 2, so that's actually 8, and then 5 times 1, so 8 plus 5, we have a total of 13 oxygens on the product side. So if we do the same thing that we did earlier, if we let's say multiply at this point oxygen by 13 over 2, then we have already balanced the reaction. Again, this is perfectly valid. But if we want to get rid of the fraction, again, multiply everything by 2. Okay, so that becomes 2. And then this one is just 13. And then we have here 8. And then this one is 10. There you go. And that's the balanced equation. Now, you can also be given problems like this in which this is just a worded problem and you'll be asked to basically write the equation. Okay? For this one, you need to know what this one is, what potassium hydroxide is, and then what these products are, what the chemical formulas are. So aluminum sulfate is just, remember, aluminum SO4 3. Okay, I'm not going to go over how that one's named. Again, you need to know your cations and anions. And then that will be plus potassium hydroxide. Okay. Now, by the way, the phases here are given, so let's put this as an aqueous solution. This is aqueous. Okay. And then this goes to potassium sulfate. Aqueous. 2. Okay. Plus aluminum hydroxide. Aluminum hydroxide. Okay. Which I think is actually a solid, but we'll discuss that in chapter 6. Okay, I'll say let's balance first the aluminums. Okay, so there's 2 aluminums in the reactant side. There's 2 aluminums on. There's 1 aluminum rather on the product side. So let's put a 2 here. Okay, if we do that now the good thing with this one is this is actually an easy reaction to balance. This is a precipitation reaction. Okay, we will discuss more precipitation reactions in chapter 6, but the common feature is you have 2 ionic compounds reacting together to form a soluble ionic compound and an insoluble ionic compound. This is the precipitate which crashes out of solution. Okay, what we can do here is actually to count this OH as one entire entity. Okay, so right now we have 6 OHs in the product side. So to balance that, we can just add here a 6 before KOH. Okay, but doing so will actually lead to 6 potassiums on the reactant side. So to balance that with the product side, we'll put here a 3, which actually magically balances the sulfates as well. We have 3 sulfates now here on the product side as well as the reactant side. And that's it for balancing equations.